Now we will solve the second question. Now in the next example, like what we have done before, we will rewrite the recurrence relation as an minus 2 an minus 1 is equal to minus n plus 5 multiplied by 3 raised to power n. So the recurrence relation is divided into two parts. This is the homogeneous part, and this is the function f of n. And see the function, it's a polynomial multiplied by exponential. Step number 2, find the characteristic polynomial. And the characteristic polynomial, first we need to find the root from the homogeneous part, which is x minus 2, and then we need to find the root from the non-homogeneous part, which is x minus 3 raised to power 2. And why it is x minus 3 raised to power 2? Because this is a polynomial of degree 1, so the root should be raised to power d plus 1, and this is b raised to power n, and b is a 3, so x minus 3. So what are the roots? The roots 2 and r2 is equal to 3, and r3 is also equal to 3 because we have repeated roots. Now we need to find the general solution, which is the general solution. It will be an equal to, the one that is obtained from the homogeneous will be c1 times 2 raised to power n, and the one that is obtained from the function f of n, it will be a times 3 raised to power n plus bn times 3 raised to power n. So we have, from this general solution, we have an h is equal to c1 times 2 raised to power n. And for an particular p, it's equal to a times 3n plus bn plus 3 raised to power n. So the name for each of them, for each part, this is homogeneous solution, and this is the particular solution. So we have some constants from the homogeneous solution, and we have some constants from the particular solution. Now we need to find the constants. Again, we will use two methods. So number 4, finding the constants C1, A, and B. And we will find them in method number 1. Method number 1 will be from the boundary conditions. So we have 3 constants, so we need 3 bounding or boundary conditions. We are given only one for the initial value, so we need 2 more. So we need A1 and we need A2 from this equation. A0 is equal to 10, which is given, and we have A1, which can be calculated from A0 minus 1 plus 5 times 3 raised to power 1, which is equal to 2, and for A2 will be found from A1 minus 2 plus 5 times 3 raised to power 2, which is equal to minus 59. Now find the equations. Since A0 is equal to 10, then we will have C1 plus A is equal to 10. This is equation 1. From where did we get this? From the general solution. When n is 0, it will be C1. N is 0, it will be A. When n is 0, it will be 0. Likewise for the other values. So we have 2, and the equation we will get will be 2C1 plus 3A plus 3B, which is equal to 2, and this is equation number 2. And for A2 equal minus 59, we will have 4C1 plus 9A plus 18B, which is equal to minus 59, and this is equation number 3. Solving for the constants using the calculator, C1 will be equal to 19, A will be equal to minus 9, and B is equal to minus 3. So the solution AN is equal to 19 multiplied by 2 raised to power n plus minus 9 minus 3n, 3 raised to power n. And this is this is the solution. So using boundary conditions, we have found the solution for the recurrence relation. Now method 2, so step number 1, finding first A and B from AN P. Okay. From AN P, which is equal to A. Okay, let me reduce the size. Okay. Finding A and B from A and P, which is equal to A times 3n plus Bn times 3n. This is the particular solution labeled here. So we will use it to find A and B, and then we will use the initial value to find C1. So what is the equation, our original equation? Our original equation is AN minus 2AN minus 1 is equal to minus n minus 5 times 3 raised to power n. So I have multiplied minus into the equation. See here, I have multiplied minus inside. If this is AN, then what is AN minus 1? It is A times 3 raised to power n minus 1, B times n minus 1 times 3 raised to power n minus 1. Substitute this into the equation. So we will have A times 3n plus Bn times 3 raised to power n. This is for AN. Minus 2. Now we will put the equation for AN minus 1 from here. So what is the equation for AN minus 1? It will be A times 3n minus 1 plus B multiplied by n minus 1 times 3 raised to power n minus 1 equal to minus n minus 5 times 3 raised to power n. We need to simplify it. So we will simplify it by extracting. So it will be by distributing. So A times 3 raised to power n plus Bn times 3 raised to power n. Let's go to another line. so we don't be congested, minus, now for this value, in fact it is Bn minus B. So minus 2 times A, 3 raised to power n minus 1. Here I'm multiplying minus 2 to this term. Now I need to multiply minus 2 to this term. And remember, this term is already multiplied by 3n minus 1. So 3 raised to power n minus 1 multiply both of these numbers and then multiplied by minus 2. So it will be minus 2 Bn times 3n minus 1 plus 2b times 3 raised to power n minus 1 equal minus n minus n minus 5 times 3 raised to power n. How did we get these two terms? For this term, it is minus 2 times Bn times 3 raised to power n minus 1. For this term, it is minus 2 times minus b, which is 2b, multiplied by 3 raised to power n minus 1. Let's take now 3 to the power n common in this equation. So we will end up with a plus Bn minus 2 over 3a. And why we are having minus 2 over 3a? Because if you take a 3 to the power n common, what remains is a 3 raised to power n minus 1, which is 1 over 3 multiplied by 2, like the previous example. It will be minus 2 over 3a. Minus 2 over 3 Bn plus 2 over 3 b equal to minus n minus 5 times 3 raised to power n. You can cancel both of these. So this is the equation we have on the right hand side. We have a constant with n with a coefficient minus 1. So let us combine all those terms with an, match it with minus n, and combine those without n and match it with minus 5. So let us arrange it this way. So we will have b minus 2 over 3 b, both of them have n as common, plus a minus 2 over 3a plus 2 over 3b together equal to minus n minus 5. We will do the matching, so we will match minus 5 with this expression and minus 1 with this expression. But this expression has one unknown b. This one has a and b. So let us find b and then we will find a from the other expression. What do we have now? We have b minus 2 over 3b is equal to minus 1. Why minus 1? Because here we have minus n and this is n. So this value should be equal to minus. And from here we have 1 over 3b is equal to minus 1. So b is equal to minus 3. Now the other equation, a minus 2 over 3a is in fact 1 over 3. 1 over 3 a plus 2 over 3 b is equal to minus 5. And from here we have 1 over 3a and b is already 3, so we can find the value of a directly from here. Okay, you can find it. So a is equal to minus 9. So an is equal to c1 2 raised to power n plus minus 9 minus 3n times 3 raised to power n. Now step number 2 is finding c1 from the initial value, and the initial value is given a0 is equal to 10. So when you substitute into the above equation, n is 0, so it will be C1 plus minus 9 minus 0, so minus 9 is equal to 10. And from here, C1 is equal to 19. So when you substitute, you will have AN is equal to 19 times 2 to the power n plus minus 9 minus 3n times 3 raised to power n, and this is the solution we found from the particular solution.